second discussion is on the role of AI. We've kind of already started talking about that. This is going to be moderated by Jack Crawford. Jack is a general partner at Impact Venture Capital with over 20 years of experience as a CPA with PwC, from there to entrepreneur and to venture capitalist. He began making venture investments in 2005 with an emphasis on information technology products. Jack has developed a track record of investing in early stage companies, including the first round investment in Soft Machines, which was recently acquired by Intel for $300 million. So Jack, over to you, please. Please introduce your panel and then off you go.
Jane, thanks so much for the introduction. It's a pleasure to be here. My panel has agreed to let me kick things off with a brief overview on artificial intelligence and then dive in and talk about their backgrounds. I'm quite excited to have a world-class panel, including representatives from the US, the UK, and the UAE. So I'll talk about them just in a moment. But if we could go to the next slide, please, Nora. Just for the audience, just a quick overview on artificial intelligence and why this area is so exciting. So we have a globally connected world with massive amounts of content being uploaded daily. And an opportunity for pattern recognition. So once you take computers and machines and you allow them to learn from these patterns, you can start to make predictions and decisions, and you can even evaluate the outcomes of those decisions and effectively optimize them over time. If you go to the next slide, please, Nora. So what we're seeing is sort of AI, artificial intelligence applied. If you think about the early days of the internet, it was viewed as a niche technology, and now we recognize clearly that the internet applies to almost every major market. We should think about artificial intelligence in the same way. Artificial intelligence will apply to healthcare, education, agriculture, retail, entertainment, quite a number of different areas all listed on the screen here. And so it's been interesting to see the increase in demand in those sectors and more. Next slide. Just as specific examples, there's, some of the fastest companies in the world are artificial intelligence companies, and so they're scaling at an accelerated rate. And if you want more information, CB Insights puts out a very interesting list of some of the most interesting artificial intelligence companies in the world. Next slide. This is just a snapshot to give you some very specific examples of AI companies applied to various market opportunities. I'm not going to go through our entire portfolio, but these are companies that we've invested in. And just to give you a little bit of a sample, we have a company called AWM Smart Shelf that's facial recognition for retail environments to allow cashierless shopping. We have a robotics company that uses pattern recognition to understand when a strawberry is the right color and the right size and should be automatically picked in the agriculture space. We have a headphones company that monitors a human's brain waves to understand its engagement with the content that it's listening to. We have an omnidirectional treadmill that uses virtual reality and monitors users' patterns. So really interesting, diverse set of artificial intelligence applied. Next slide. One of the reasons why our investment firm and corporate venture groups in particular are so excited about artificial intelligence is they're looking at the forecasts of AI revenue. So on the left side of this slide, you'll see that the revenues are growing to about $120 billion in the next few years just from artificial intelligence. Corporate venture groups from around the world have gotten really excited about investing and acquiring AI companies, and they're starting to do that at an accelerated rate. Next slide. This is the last slide, and I just wanted to mention and camp on one area in particular. Within artificial intelligence, the semiconductor space is doing some very innovative things with smartphones, tablets, wearables, speakers, and others. And what's happening is I think this may be one of the hottest areas within the artificial intelligence sector broadly. There's now acquisitions that are happening on a regular basis at $1 billion or more. And you may have read recently about Nvidia acquiring ARM for $40 billion. So anyway, quite a hot space with a significant tailwind. Next slide. I am the lucky moderator of what I think is one of the best set of speakers that I've ever been involved with. We have Gordy Campbell, who is the founder of an innovative company called Cornami in the AI chip space. Focused on data encryption. He'll talk about that in a bit. Gordy was at Intel for a number of years. He reported to Andy Grove. He then spun out and launched 3D Effects Chips and Technology. He's got $4 billion worth of exits, positive exits under his belt. From the UK, we have Dr. Michael Azoff, Chief Analyst at Kisako Research. He's a global expert on artificial intelligence. And then from the UAE, we have Vinay Chandran, partner at McKinsey and an expert in AI and advanced analytics. Welcome to the panel. I'm going to dive in with questions, and I'll start with Michael. Michael, you know, I've given sort of a broad overview of artificial intelligence. You put together some phenomenal research and industry reports, including a lot of great information on the AI chip space. But you've talked a bit about, we've communicated about machine intelligence evolving into narrow AI and general AI. Could you comment on sort of AI and where it's headed in the future?
Sure, I'd be happy to, and thanks, Jack, and hello everyone. So yeah, so basically we can talk about the broad AI research across academic, industrial communities, and we can also talk about the timeline of our progress and what we have achieved and where we are in terms of the ultimate goal of artificial intelligence is to create human-like intelligence artificially. So I have labeled our current state of progress, and you've highlighted deep learning as being pivotal in the current wave. I call it machine intelligence because I don't believe we have quite reached what a lot of people refer to as narrow AI. And again, I have to say there are no standard definitions here, but generally people talk about narrow AI as being not quite at the level of general AI, which is general AI refers to human equivalent artificial intelligence. I would say narrow AI would require certain milestones to have been achieved, such as learning rapidly from a small set of examples, like the human, like a human baby can understand from a few examples. And at the moment, AlphaZero, the DeepMind Go playing champion algorithm required millions and millions of examples to have achieved its learning capability. So some major challenges, I believe, in terms of the ultimate goal of AI, but this is not to take away from our current era of machine intelligence and deep learning, which is, as you've highlighted, is making amazing transition from the research labs and into the real world with some amazing applications. And this is really where a lot of the investment is going. But I just wanted to put where we are now with deep learning in the context of the broader AI research program.
Yeah, very helpful. Gordy, you know, it's been interesting to look at AI applied and look at the revenue forecast. I mean, $120 billion in the next few years from AI. I'd love to get your take on the AI market. And maybe, you know, obviously we're an enthusiastic investor and board member in Kornami. Maybe you could just take a minute or two and tell us, you know, how you think Kornami is going to sort of revolutionize the AI industry. Oh, it looks like you might be muted.
Gordon, can you unmute?
A good way to understand what's going on in AI is to understand the transition we went through from the last century to this century. The end of the last century was primarily a PC-driven era, and it was characterized by huge program lines of code, hundreds of millions of lines of code in Office and hundreds of millions of lines of code in Windows. And very, very, very small databases. The internet changed that, and in the beginning of this century, we now have vast, unlimited data sets and reasonably small programs that sort through and try and manage that and learn and sort. So it's been a huge transition. And as Jack mentioned, we're a computer chip company. So what we're doing is we recognize that there was a huge disparity in terms of what the computer chips of today were designed for. They were designed for that old era, and they're woefully inadequate for today's world. And that's why you've seen this furor of activity in the chip world to try and come up with an architecture that can deal with this huge transition in the data set world. We are building what we call a compute fabric. And the way I would explain this is that the computer architectures of today, which is what's been invented for the old world, are much like a piston engine. And as you know, all of the modern airplanes have gone to jet engines. And our architecture is much more like a jet engine. It scales, it can be made bigger, it's more powerful. And a good way to think about it is if you think of data as the gasoline, in the architectures of today, the piston engines, a little bit of gas is brought into the cylinder, it's ignited, and it has to go through the 4 or 5 cycles, and then it's expelled as you know, exhaust gases, and that provides the propulsion. In our architecture, we're much like a jet engine. Our data flows into the engine and through it, and it's very rapidly, and the engine can be scaled as a compute fabric much larger. So we have the ability to deal with these things very efficiently and to handle the massive databases that AI and machine learning require.
Mm-hmm. Really interesting. Okay, thanks for that, Gordy. Vinay, I got a chance to come out to Dubai and attend the Kauffman Fellows Summit in February and learn a little bit about sort of what's happening in the Middle East broadly from a regional investment standpoint and from an opportunity standpoint. But you're there on the ground in the UAE. I'd love to get your perspective on how AI is sort of being leveraged in the marketplace that you're operating in, and get just your perspective on the market in general.
Thank you, Jack. Both regionally and globally, AI, as you pointed out earlier, has a huge economic value, right? So when we had done our research, we had identified around 9.5 to 15 trillion in economic value through AI. And these are through advanced techniques and clustering algorithms to deep learning techniques. We've been working with a lot of institutions in the region trying to see how do you apply and adopt it. Some of the learnings that we see is that as you look at AI and the application of AI, we are seeing early adoption across a range of sectors. For example, oil and gas sectors have traditionally and historically been early adopters of advanced process controls. You know, they've been doing that for the last 10, 15 years. And if you look at the institutions in the region, they've applied the latest of those techniques. But what they're looking at now is, given the current oil prices, et cetera, they've been trying to see, how do I apply AI to get the additional dollar per barrel in profit improvement? And we're seeing a lot of refineries, for example, explore that option. In the same case, we're seeing retailers like banks also apply machine learning techniques to identify the hidden affluent segment. Again, applying AI to some of their business challenges in terms of how do you drive additional growth in a market that's already crowded. Telcos, on the other hand, a lot of telcos in the region have lost their annual growth rates of historical times. And so now they're trying to see, okay, how do I be more personalized in the offers and campaigns to drive more value from my existing customers when growth can't be available through new customers? So a lot of the trends that we are seeing in AI adoption has been around specific business challenges and actually using AI to capture either business improvement or new product revenues.
Yep, makes great sense.
So yeah, that's at least what we are seeing.
Michael, you know, the semiconductor space, when you look at AI and semiconductors, it's obviously a hot space. You've put out what I view as sort of world-class research reports on some of the activities in AI and semiconductor. And now, obviously, recently, a $40 billion acquisition of ARM by Nvidia created an incredible tailwind for that whole segment of the AI space. Can you comment on sort of that industry sector and sort of your sense of the momentum there?
Sure, and thanks for your comments, Jack. So the acquisition by Nvidia has, I think, if you look at how Nvidia has grown, through the serendipity of using the general purpose GPUs that it brought out around 2010, and deep learning was ported onto that, and really deep learning took off from that point because it needed that extra acceleration that the GPU was able to provide. So the whole the semiconductor field, as you mentioned, has really been about the accelerator chips, and the huge need, the appetite for that computation. That CPUs just can't cope. I mean, you know, you take an online cloud provider and they're running recommendation engines, and the CPU just can't cope with the extent of computation that's needed. So a vast market. Nvidia has called itself, repositioned itself from being a GPU company. It's calling itself an AI platform company. And really, until it bought ARM, I think it was a one-trick pony, because ultimately, I think in the long run, something's going to change, and the GPU may not be the ways and means of doing things. So I think the company is looking long-term to remain a permanent feature in the landscape, and ARM, I think, is part of that strategy. It needs to broaden out. I think that may well have been a key decision. I mean, I've advised Nvidia that it needs to broaden out beyond GPUs if it's really going to be the AI platform company. Yeah, so I can talk on and on, Jack.
Yeah, but it's been an interesting development, and it's been fun to kind of watch the space heat up. I guess one of the other subsegments of that I wanted to make sure Gordy commented on, and maybe then I'll circle back to you and Vinay. Gordy, you know, privacy and security are becoming more important every day. We had a portfolio company focused on cybersecurity for government markets that was acquired by Thomson Reuters earlier this year. Data security itself is like $105 billion market opportunity that is being revolutionized to some degree by something you know quite a bit about, fully homomorphic encryption. Can you just describe sort of what FHE is and why it's such a big deal, and how Kornami is, you know, sort of differentiating using its focus on fully homomorphic encryption? You're gonna have to unmute, Gordy. You're gonna have to unmute.
Thanks, Jack. We actually had done some work with DARPA, and DARPA had investigated the security and privacy quite extensively. And they came to the conclusion, basically, that there will never be a secure computer, a secure data center, or a secure cloud. Now, and when they say that, obviously everybody is trying to make them as secure as they can. The problem is that they have a lot of backdoors and a lot of ways that it's difficult to protect. So what DARPA came to the conclusion is that what they really needed to do was to provide a secure data. And forget about trying to secure you still will try and secure the computer and the data center, but if you have a secure data, then you don't need to worry as much about the different problems that you get into if your computer or your data center is compromised. And it turns out that about 10 years ago, a PhD candidate, Craig Gentry at Stanford, proved that a technique called fully homomorphic encryption could provide secure data. And the way this works, a company has their financial results, they want to take it to the cloud, have it processed, and return to them. The way that works today is they encrypt it, they send it to the cloud, but then they have to send the decryption key to the cloud provider and have them process it, then re-encrypt it and send it back. And the problem is that it's exposed when you decrypt it. So in fully homomorphic encryption, you have the same company encrypts the data, sends it encrypted to the cloud, it's processed in the cloud encrypted and sent back. And so the data was never exposed, completely secure and completely private. Now, this sounds really fabulous, and it sounds like a great solution. There is a problem with it, however. The gotcha in this secure data technique is that the compute intensity to process the encrypted data is about 1 million times more compute intensive than it would be if it were processed unencrypted. And to put this in context, we looked at 100 million data entries that were encrypted and processed in AWS in 24,000 Intel cores, about 12 racks of equipment. And the 1 million entries took almost 5 days to process. Obviously, that's not very realistic. Now, one of the things that I mentioned is that our computer architecture that we're doing at Konami is like a jet engine. It's what we call a compute fabric as opposed to a standard computer chip. And when I say compute fabric, we can put lots of our chips together to create a larger compute fabric. And so we can handle problems like this, and we can handle the 1 million times more compute intensity needed to do something like this in real time. And so mid next year, when we have our first products out, one of the markets we will absolutely be providing products to is fully homomorphic encryption. And so there is an absolutely wonderful solution for secure data a little less than a year away. And we're pretty excited about that. And I can tell you some of the customers are pretty excited about that as well.
Thanks for that, Gordy. Michael, did you have any quick additions on FHE in general and your thoughts on that marketplace?
Sure. So I defer to Gordon as the expert on the topic. I have been tracking this concept, and it's absolutely amazing how you can perform computation on encrypted data and achieve results. I think a key thing here is what kind of calculations you can do under the shield of the encryption. So in a way, it's a question for Gordon. Is it only certain types of transactions that you can process with FHE, or how broad is it in terms of what you can do under the cover?
There's what they call homomorphic encryption, which is what I would call, that's homomorphic encryption light. And that uses basically a minimal set of calculations. Fully homomorphic encryption actually is a much more difficult, much more advanced capability. In fully homomorphic encryption, you can pretty much do anything you want, and it's just a question of compute time. If you have the right architecture, however, and to put this in perspective, we will require, I think, not 12.5 racks of equipment, but our first fully homomorphic encryption will be 16 servers, I think. And so it's probably a little less than a rack of equipment. And that gets us down to a real-time ability to process something that took AWS 5 days.
I know we're running out of time. I had one last question for Vinay. There's been an acceleration of the innovation curve with COVID-19, right? We are obviously doing more online Zoom calls now than we were ever doing before. Maybe the forecast for 4 years from now are happening today. Online education, food delivery to the home, all these types of things have been dramatically accelerated. Do you have any sort of final comments as sort of, what are you seeing as organizations navigate sort of to this new normal? Any trends that you're saying that you're excited about just as we wrap up the panel on AI here? I'll give you the final word.
Thank you, Jack. Yeah, so actually what we've seen in the region, actually even globally, is an acceleration or adoption of AI as it relates to helping businesses address some of these challenges. So for example, a lot of institutions have looked at solving their supply chain issues using AI. better forecasting, better scenario planning, sorry. Also looking at AI to drive workforce management, right? How do you actually apply retailers looking at their footprint and making sure that their workers are safe while the COVID crisis continues. So we are seeing a lot of institutions applying AI specifically to the challenges that they face in the new normal, but also they're also then using the same opportunity to tackle historical challenges that they've faced in adopting AI. For example, these functional silos that used to exist is not as rigid anymore. You know, people have been much more agile in reacting to the COVID-19 crisis, and you find that these cross-functional teams have been formed organically to try to tackle these challenges. So we see a lot of that happening as institutions become much more dynamic and try to figure out how do they tackle the problems that they're facing now, as well as investments into tooling and technology, trying to automate as much as possible. Ingestion, data security, for example, was a question that came in the chat. All of these things we're seeing investments going in as institutions try to actually capture white spaces that exist, but also adapt their business models to be much more efficient.
Thanks so much for your comments. Jane, back to you. If there's any other questions you want to cover from the chat, I know we're short or out of time. I want to make sure to give it back to you. Oh, Jane, you're muted. Just to...
Yeah. So Vinay, maybe just one last question for you. Are there any regulatory challenges that you see with in this region, for example, with data hosting monitoring for AI organizations?
Yeah, so I think the regulatory environment in the region has been evolving actually in the right steps. So, for example, in the UAE, you have the ability to host yourself in, for example, in the Microsoft cloud. So there are certain things that are actually happening, and where we see cloud adoption increasing, and therefore institutions can leverage cloud-based AI capabilities at a much more larger scale, and so that's one thing we're seeing. At the same time, I think there was a comment on the chat, which was how do you ensure privacy and information sharing, especially both from local regulations as well as when you look at GDPR, etc., and the impact it has on institutions. So we see a lot of actually institutions thinking of security and regulations as they look at adopting AI. So that's a bit of the technique that a lot of at least our clients have adopted, which is you can still do a lot of things in terms of, for example, personalization of offers through encrypted data, masking, etc. But they're being more thoughtful about that on the individual applications. So that's been a lot of the discussions that we've been having with our clients on this, on how to actually adopt security and drive that. Great. So it's not really a limitation, it's just been something that they've taken into account.
Yeah, actually, let me just add a little bit to that. One of the big advantages of fully homomorphic encryption is it allows you to take something like health records, for example, and still allow the health records to be searched for different disease parameters or health parameters by different organizations without violating the privacy of the individual. It allows somebody like Google or Facebook to actually have data that they can go out and sell without violating the privacy problems. And then to take it one step further, one of the things that will happen is we will see machine learning being done while encrypted as well. And you ask, why would anybody want to do that? Because that complicates the machine learning process tremendously. A good example is Tesla. And it's widely rumored that the Chinese have broken in and taken the Tesla driving AI model. And if you had that encrypted and you had the ability to protect it, then if somebody breaks in and steals it, they don't have the benefit of all the millions of dollars that you put in and try and train that program to have a state-of-the-art self-driving car. So, you know, as we do more and more in AI, it's more and more important to protect what we have. And this is another way that we can provide protection, security, and privacy.
Jack, I think one more question, because I think it's just such an interesting discussion that's going on. This is from Johan. One of the major challenges on successful adoption of AI in the region remains lack of data availability and depth. And maybe, Vinay, question for you, how do you see some of your clients addressing this challenge?
Two thoughts on this one. One is increased investment in data tooling and technology, because what you find is a lot of, actually AI has been also applied in the data ingestion and data processing side. We see a lot more now. So things where you had to bring together data and manually actually cleanse it and clean it and actually get the right depth, you see a lot of AI algorithms actually helping there. So we've seen clients adopt those techniques to address the data challenges that you see. We're also seeing institutions look to partner with others to fill data gaps that they have currently. So we are seeing a few ecosystem conversations also happening as institutions look to apply AI in a data, let's say, limited environment. That said, maybe the closing thought on this one is a lot of our clients also don't realize the data that already exists. For example, 90% of the data that asset-intensive industries generate are not used. They just lost because they're not stored, they're not actually processed or applied. So I would always challenge my clients to think hard on where's data being generated and how are you applying all of it or processing all of it.